of the CH bond of an alkyl group directly attached to an atom of unsaturated system or to an atom with an unshared p orbital. Now yes, this definition seems quite confusing. So let us understand this with the help of these two examples. In the first case, we have a carbocation. So you can see that a positive charge is present on this carbon atom and therefore we have a carbocation here. So attached to this positively charged carbon atom, we have a CH3 group, that is an alkyl group. So this system is actually CH3 CH2 positive. Now this carbon atom has 3 sigma bonds, 3 CH sigma bonds to it, and this positively charged carbon atom has 2 CH sigma bonds, and in addition to it, it has an empty p orbital, which can also be termed as an unshared p orbital. What happens in hyperconjugation is one of the sp3 hybridized orbital of carbon aligns itself in such a way with the p orbital of the carbocation such that the electrons involved in this CH bond can be delocalized into the empty p orbital, as you can see in this figure. Delocalization means that these electrons that are involved in this CH bond can migrate or move towards this empty p orbital. Now you can see that there are 3 CH sigma bonds here. So any of these 3 sigma bonds can get delocalized into this p orbital. In the similar manner, if we talk of an unsaturated system, that is a system which has a double or a triple bond, like I have depicted here. So this system is actually CH3 CH double bond CH2. Now you can see that this system is an unsaturated system and it has a single bond, that is a sigma bond, and a pi bond is formed by the overlapping of these p orbitals. Now again, when hyperconjugation occurs, the electrons that are involved in the sigma bond will get dispersed or will move towards the p orbital of the carbon atom. So now let's read the definition again. So it says that hyperconjugation involves delocalization of sigma electrons of CH bond. So we have a CH bond and we have sigma electrons. So delocalization of the sigma electrons of the CH bond of the alkyl group that is directly attached to an atom of unsaturated system. So this is an unsaturated system, or is attached to an atom with an unshared p orbital. So this is an unshared p orbital. Now let's consider these two cases more closely. So in the first case, we have a hyperconjugation effect in which we have an unshared p orbital. So we've taken the example of an ethyl carbocation. So you can compare this structure with this given. We have CH3, so we have CH3, then we have CH2, and this C is positive here. Now what happens is, these sigma electrons will move towards the unshared p orbital of this carbon. As a result, a double bond will be formed between these two carbon atoms and we get an H positive ion here. Now since we have 3 carbon hydrogen sigma bonds, any of these 3 sigma electrons can be involved in hyperconjugation. So if this hydrogen was involved, the second one, again a double bond would be formed between these 2 carbons and a hydrogen positive ion would be produced here. In the similar way, a third case can be when this hydrogen atom participates in the hyperconjugation, and we again get a double bond and H positive ion here. So these three structures are called the hyperconjugative structures, and since there is no bond between the carbon and the hydrogen atoms in these structures, hyperconjugation is also called no bond resonance. Now, although a free proton, that is H positive, is present in these structures, it is still quite firmly or quite strongly bound to the pi electron cloud that exists due to this double bond, and hence this H positive ion is not free to move. Now, this type of overlap stabilizes the carbocation because the electron density from the adjacent sigma bond helps in dispersing the positive charge, and therefore hyperconjugation is a stabilizing effect. Now, let's look at the next case in which we have an unsaturated system. So, here we have CH3 single bond CH double bond CH2. Since we have a double bond here, so we have two p orbitals that are overlapping each other and form a pi bond. So, again delocalization of the sigma electrons involved in this bond will take place. Hence, this bond moves between these carbon atoms and the double bond moves forward, creating a negative charge here. So, again we have a proton, and since we have three sigma bonds on the carbon atom which is next to the double bond, therefore, three cases of hyperconjugation are possible. So, all these three structures would be the hyperconjugative structures. So, from these structures you can see that hyperconjugation occurs through the hydrogen atoms that are present on the carbon atom which is next to the double bond. Now, more the number of such sigma hydrogen atoms, more would be the number of hyperconjugative structures, which means that we had three sigma bonds here. So, we had three hyperconjugative structures. In case we have more number of carbon atoms involving carbon hydrogen sigma bond, then we will get more hyperconjugative structures. More the number of hyperconjugative structures, more would be the stability. So, by looking at this, we can say that the order of hyperconjugation decreases in the order, the stability of the hyperconjugation effect decreases in the order. CH3, which would be the most stable because it has three carbon hydrogen sigma bonds, followed by CH2 CH3 because now the number of carbon hydrogen sigma bonds has reduced to 2. Then comes CH2 CH3 whole twice, where we just have one hydrogen atom that can be involved in the hyperconjugation, and the least stable case of hyperconjugation would be when we have a tertiary carbon atom. So, obviously this carbon atom does not have any CH bond, no sigma electrons are present, hence no hyperconjugation would be shown in this case. So, contrary to the inductive effect for which a tertiary carbon is the most stable, in hyperconjugation a primary carbon, actually a methyl group, is the most stable, followed by primary, then secondary, and the least would be the tertiary carbon. So, I hope the concept was clear to you. Still, if you have any queries, you can always write in the comment section. In the next video, we will discuss the significance of the hyperconjugation